There's designated networking time at the end. But until then, absolute silence, please. We're going to be kicking off any second now. Thank you very much for joining us this evening. Apologies for the 7-minute late head start. I'm going to blame it on the MA. I was a little bit late, and these things always take a little bit longer. But really delighted you're all here to join us tonight. It's going to be a really, really interesting event, actually. A lot of these end up really, really good. Just the format of these things with like lightning talks and a really in-depth Q&A, you tend to get a much better outcome than just like long, stuffy talks back to back. So it's a little bit more exciting. We've got an incredible lineup of speakers, but a few sort of housekeeping things I need to do first. Also, this is online and it will be streamed, so thank you for those that are joining us online. Really appreciate that as well. If anything does drop out, the recording will be sent to you and all that, so don't panic that you're going to miss the absolute show that's going to go on in the room. There are no fire drills planned, so if anything goes off, follow me as we scream out the door to the fire area. Yeah, I'd like to thank Live to Air for setting things up, miking us up and making this all look really smart and online and very clever, and giving access to like a load of other people that could maybe not get to Edinburgh but are really interested in this topic. I think it's an important one. This community only grows by these kinds of events and this kind of work, so opening that up to the wide world is really important. As much as we all love Edinburgh, it's hard to get there. So, yeah, if you are that way inclined, streams at go, live2air.uk. This will be on YouTube to follow it up and chase up any questions. Really want to thank the sponsors that kind of make this available. Like, these things aren't free. It takes time, effort, money to plan, organise and pay for rooms and pizza and things like that. So today we're sponsored by Translational Community ITPA. They are based out of Edinburgh Uni doing some sort of cross-research support and funding into like human health and well-being and that. So massive thanks to them for enabling it and just doing an all-round cracking job of like something really positive and warm that's related to the sector and just all-round good, right? The other thing I wanted to do was talk a little bit about what we're going to go through in the session. So you'll be done with me in a minute, don't worry. We will introduce the speakers. There's going to be 3 talks of 10 minutes each. We're going to try and get them snappy, reserve questions for the end, and then once that's done, we'll get them all up here in a panel, and we'll have a good like 40 minutes to ask really good in-depth questions and try and get a bit of discussion going. So think of questions, tap them out on your phone so you've got them ready for that. If like you can't remember them for the 30 minutes and all the stuff that will come out. For those that don't know me, my name's Adam Strocker, professional loudmouth. I had a career in data and AI. I do a lot of work with the data lab, and it's just an honour to be able to do stuff like this and be in rooms like that. I did a talk here recently about how I really think, like, in my career, community's been a bit of a superpower, and so I like the stuff. The data lab community is a brilliant thing to be a part of, to have access to both in person and online. I would highly recommend joining it. So for those of you in the room today or online that maybe this is like your first interaction, maybe you know one of the speakers and you're here for moral support, or maybe you wanted the free pizza and you weren't really sure, but loads of events get run. There's loads of like access to funding, support, like professionals, there's mentorship programs. Like, I can't stress enough how valuable this as a resource is, and it's free. So there's a QR code there, but come and find me or some of the other guys and girls that run the data lab that are here today and stood out there serving pizza and drinks. Like, it's a really, really good event, resource to get into and do more stuff like this. I think these are running monthly, is that right, Stephen? So there's like a different theme every month. You may have to put up with me for some of the other ones if you're unlucky, but there's like finance and there's sustainability and so on and so forth. So what's today about? We're going to talk about a few things like AI in healthcare, some of the challenges that like that means. Everyone wants an AI nowadays, and I'm a consultant, right? So like we'll try and flog AI to anyone, but we want an AI, and no one really knows what that means. And it's all well and good if you're like optimizing shopping carts or like ads, where it's like nothing super importance at risk. But when you're in the world of like healthcare and well-being, like you can't get stuff wrong. This is a high risk, like really important domain, and the three people we've got today know the pains and the challenges of doing it right, and like in a heavily restricted, like heavily governed environment. So we're going to talk a bit about that. As we get into the panel discussion, we'll pit them against each other and see if we can get some good arguments on the go. We can talk a little bit about skills and stuff as well. I think that's a really important topic, not just like everyone they want the technology, but it's like that's actually the easy bit when you've got the right people. Getting the right people is really, really hard. People that care, people that know. So understanding like what some of the panels think, and then when we get into the bits later on, what some of you guys think, that'll be really, really interesting for us all, I think. And then only other stuff I've got to talk about is, jump us on socials. So if you're on Twitter, X, whatever it's called, it's @TDL Community. If you're on LinkedIn, it's tag @the Data Lab and try and get a bit of buzz, because again, this is a free service that's like come out of Scottish Government, and like tagging it and building some buzz around this helps give back a little bit as well. It's low lift for you. It actually will make an impact for Data Lab, and maybe someone out there really needs the services that are here and they've just never heard of it before, but they know you. And so it could be the thing that changes the trajectory of a company or a team or something like that. At the end, we will have time for networking, so you will be allowed to speak later on. And meet each other. We're also, last time they ran this, I wasn't here, but they did a thing called community call-outs, and it's a really cool idea. So we'll do like it's like an open mic, and I'll be quite strict that no one hogs the mic, but I'll wander around. If you've got like a thing you want to plug or promote, you want to give a shout out to someone that's like done a great job, or anything you think this community, like you want to sort of talk about, I'll wander around and you can get 30, 45 seconds to do that. And it was really powerful last time, a good thing for the people in the room, and we'll see. It might be a disaster, but I think it'll be good fun. I'm keen to see how it plays out. So I think that may be all you have to part with from me for now. So we're going to have our first 10-minute talk is going to be delivered to you by Simon Rogers, who's going to join me on the stage. Simon's a senior technical consultant in data analytics for a little-known organisation, NHS, National Services. Simon, if you'd like to give a bit of a wider introduction to... Yeah, can I take that? Of course. Thank you very much.
Excellent. Is this on? Can you hear? Yep, great. Yeah, thanks, Adam. So Simon Rogers, I'm a senior technical consultant at NHS National Services Scotland. Now, NHS is well known. National Services Scotland isn't that well known, as far as I can tell. We're a specialist health board providing services across the NHS in Scotland, right? So to the regional health boards and to the national health boards. And NSS is massive and spans everything from blood transfusion to procurement, and then to our little bit, which is in business intelligence. Just a bit on my background. So I was an academic for like 11 years or so in a different computer science department. So it's a bit uncomfortable being here, but I'll do my best. So there's a couple of things I want to talk about. I've got 10 minutes. Are you going to keep me right for time? Oh, yeah, you just started it. Oh, you took a minute off. So I want to talk a bit about the data platform that we run in NSS, and then talk a bit about an AI case study that we've been working on, which is not clinically facing, and I kind of chose that for a reason, but I'll come to that. So firstly, SIA. So we in business intelligence in NSS run this platform called SIA. It's kind of a national data platform. At its heart is a corporate data warehouse in which we have a huge quantity of health data for the whole of Scotland. So things like all prescriptions going back to 1981, A&E attendances, and our kind of core role historically has been taking data in from lots of sources, structuring it, linking it all together, and storing it in this structured way. So all sorts of questions can be answered with this data. It's used very widely. You might not necessarily know that you're using it. So anyone who's used data in Idris, for example, there's a good chance some of that data came from this platform. So users across a whole bunch of sectors, but there's sometimes an intermediate between us and the users, right? So you don't necessarily see us. Built around that is a team of about 40 to 50 people now. It's kind of going up at the moment with expertise in data warehousing, database development, data visualization, data virtualization, security, and increasingly now people, say like me and others who've come in with kind of more of a background in some more advanced analytics, machine learning, AI kind of stuff. And we produce loads, for our customers, loads of reports, thousands of dashboards, like loads of users. So it's kind of there in the background. You probably have seen stuff that's come from it, but you might not have interacted it directly. Just what's happening next, I don't want to talk to this very much because I haven't got much time, but we are in the process of moving from a kind of on-premises model into the cloud, so moving to AWS. And I think from the point of view of this kind of talk, one of the exciting things there is I think traditionally, on-premise, we've had this big kind of database infrastructure, but it's kind of challenging to get big compute to that data. Whereas in AWS, we can now get compute close to the data. So in terms of doing things like AI, this is kind of really exciting. OK, so that's who we are. A case study on something kind of a bit different in health, right? So I think when we think about things like AI in health, you think about clinical applications like diagnostics, reading, X-rays, stuff like that. But I think certainly the view I've had working in this organization is there's a whole lot of stuff within health that's not that can also be improved through the use of more modern techniques. So I want to talk about some calibration work we've done with a technique called Bayesian optimization. You may have heard of that if you've kind of worked in machine learning. So this is around a project called Host Systems Modeling. Now this is a kind of Public Health Scotland project. So we work with Public Health Scotland for this. It was built kind of during COVID. It's a big stochastic simulator that sits there simulating people going through hospitals in Scotland, right? And it can simulate at the Scotland level, it can simulate at a health board level, it can simulate at an individual hospital. And it sits there and it simulates individual made-up people going through this journey. And the idea is that those simulation results can be used for planning, right? So it's used for forecasting demand for acute hospitals. It's also increasingly used for generating scenarios around COVID and flu for the government. It said winter planning on the original version of this slide, but we're still doing this now, so this isn't winter, right? So this is still happening. There are still these things around. So it's a discrete event simulation. It's programmed in R, this thing, right? It sits there, chugs away. It runs whenever someone wants to run it. And our role traditionally has been we deploy it, right? So we built an API around this model, and we have a big ETL platform job, which means when someone wants to run it, they deposit an Excel file in one place, it gets picked up by the job, it gets loaded into the data warehouse, the API gets called, and the results go back into the data warehouse, and then get visualized on dashboards. But the key thing here is that this model has to be calibrated, right? So every now and again, someone at PHS has to sit and do manual model runs and try and work out how they need to tweak some of the inputs to make the model look closest to reality. And that's really time consuming, right? So someone sits there, they have to put inputs in, they get things out. There's a lot of inputs to this model. They typically tune a small subset. And it's slow, right? The stochastic simulator, if you're simulating the whole of Scotland, it can take over maybe a couple of hours per run. Now, some of them, if it's health board, it's quicker. So if you're running Shetland, it's pretty fast. But if you're running Scotland, it's pretty slow, right? So that's a really tedious process. What we've done recently is develop a Bayesian optimization approach, right? So this is kind of standards in the machine learning field. And how this works is you imagine you've got this black box of the model sitting in the middle. The Bayesian optimization maybe picks a random set of input parameters, calls the API, right? Gets the results back, processes them, compares them to what reality looked like, and gets some kind of error signal. And then it says, I'm going to try and fit a predictive model between the inputs and the error. So I want to be able to predict the error from the inputs without using the model, and then uses that predictive model to work out where it should go to next. And it has a kind of trade-off between exploration and exploitation. And there's a lot of benefits to this. Mainly, it doesn't require someone sitting there, pressing go, waiting for an hour, getting the results back, pressing go again, right? There's a couple of little plots that just show for a one-dimensional example. So if you imagine this was the parameter that the input you're trying to optimize. These red dots are where we've called the model API. So this is a real example for one dimension. And we've got this machine learning model that's trained to fit a curve through this. It's a Gaussian process, so it's got this confidence thing. So anyone who's doing machine learning, if you're not doing Gaussian processes, you probably should, right? Because they're kind of amazing. And I'm willing to argue about that. So, and then what happens here is you then stick an acquisition function over this that says, well, the best place to go is here, because it looks kind of close to the minimum, but there's kind of quite a lot of uncertainty, so I learned something by going there. And this works in 1 dimension, 2 dimensions, 3 dimensions, like as many dimensions as you want. So yeah, just that's kind of how it's implemented in our setup. So yeah, cooler stuff. It's implemented in R. We wrap it up in a Docker container. It sits in Kubernetes. There's all sorts of cloudy stuff there. So what's good about this? Well, it used to take a long time. It now doesn't. So for example, I ran 5 calibrations yesterday just by pressing go every now and again on my laptop. That would have taken someone over a week previously. So it is a massive benefit, right? And it frees up those staff to do something more useful. Well, this is useful, but frees them up to do something that humans can do. It's just as good at finding the optimals. Models uncertainty and output. I've got a minute left. I'm not going to go into that, but I can talk about that if you want. And a key thing here is this kind of unknown benefit. So when we started this, we thought all we want is the best inputs, right? We want the best inputs to get the output that matches reality. But what you actually get with this is this kind of queryable predictor of the model output. So once this is trained, once you've done a bunch of API calls, you've got this trained thing, you can say, what would happen if I set the inputs to this? And it can predict pretty well what would happen to do that. Aggregated, right? It's not a replacement for the simulator. And some quick examples of that. So this is some real results. This is one of the parameters that gets varied. And basically saying, well, if I fix 2 parameters, the reason why I'm fixing them is kind of hard to draw a 3-dimensional thing. Right? If I fix A and B, what should I do to C to get output to match reality? And this is basically saying, well, if I fix them like this, 8 and 20, don't worry about what that means, I should set it about here, right? This gives me the minimum error. If I change it to 5 and 10, I should move it over to here, right? This is, so if someone's sitting and someone's using this model, this is really, really powerful to get this kind of information when it's taken a long time. And you can do the same thing. This is kind of fancier 2-dimensional plots. If I fix 1 parameter, what can I do for B and C? And you're seeing, you can see these quite complex relationships between the parameters, which would be a really hard thing for a human to uncover by probing this a little bit. 14 seconds. Conclusions. Another minute. Oh, okay. So quick conclusions, right? So this is from a kind of this individual thing. This is a big bottleneck, and we've freed up the bottleneck, right? It's getting used quite a lot. We have this now. We have a standard operating procedure with PHS. They send a special request in. We get it kicked off. It gets run. It's all good. It is an example, I think, of many where there's big efficiency savings if you can kind of see the process in the right place. So if you can see what people are doing and say, well, actually, there's something we can do. And it doesn't look quite like what people would think of when they say, I want to use AI for health, so I'm going to diagnose things. And made possible with that within our SEER platform. So this is all running on AWS. And yeah, any questions at the end, I guess, or by email. Cool. Thank you very much.
Thank you very much. I toyed with Gaussian optimization stuff a little while back, and too hard for me, so I did something else. Really good talk. Yeah, please write your questions down. I remember them. I think there's some really interesting stuff to learn there. I've got some queries about the number of tools and skills and expertises used to do a thing like that is non-trivial, and how you build that kind of team. So excellent talk there. Let's follow that up and keep pace with Ivona Viskovic from the AI Centre of Excellence. Ivona is at Canon Medical Research Europe. Ivona is a technical manager and will be joining us to talk all things healthcare.
Good evening, everyone. Can you hear me okay? Yeah. Really nice to see you all and see such a good turnout at this event. Hard act to follow, so I'm going to do my best. Adam already introduced me, but yeah, I work at Canon Medical Research Europe. My background is actually not medical and it's not science, it's engineering, and I spent 15 years working in consumer electronics before making this change. So maybe, like you, Simon, also feel a little bit uncomfortable, but the good thing is we all learn every day and from each other. Yeah, I'm really passionate about tech for social good, not just healthcare, but other things that I know Data Lab is a big promoter of, which is also one of the other reasons why these community meetups are good for our learning. So you probably heard about Canon as the camera company, but you maybe don't know that Canon Medical exists. So globally, it's referred to as Canon Medical Systems Corporation, and it does have that mission of transforming people's lives through putting diagnostic solutions in hospitals, whether that's CT, X-ray, ultrasound interventional equipment, and healthcare informatics. Here in Edinburgh, we have Canon Medical Research Europe, about 150 people, 100 of which work on research and development. And we are referred to by the company as the Pioneering R&D Centre. And really, it's that, every company will have its motto. Ours is Made for Life, but that motto really comes to life in the work that we do, because we turn up for work every day making sure that something that we develop will ultimately make it into a hospital or clinical setting and make a difference. We've got different teams working on platforms and engineering tech enablers that support research and development, but also groups that do healthcare informatics, image analysis, visualization, and AI research in the broader sense. Smart modality refers to all the technology that's used for as part of our scanners and to improve the quality of imaging when it happens in the scanning environment. Just a couple examples to start off is we've got some luminance technology, which is high quality rendering in 3D that really helps get very realistic pictures and information as early on as first trimester of a pregnancy, as shown there. And then we have algorithms that help interventional procedures. So embolization plan algorithm helps the clinical user track vessel paths from a user-specified catheter position up until the tumor, which enables them then to carry out a TACE procedure, which means an injection of chemotherapy into the right location. So when we take a step back and think of how do we inject AI in this technology and how does that help in clinical practice? The most important thing is that AI is here to assist the clinicians and then patients. It's not here to replace them, and it's to help assess, diagnose, and treat people. A few years ago, there was a big trade show, RSNA, which stands for Royal Radiological Society of North America, and Siddhartha Mukherjee, who's an award-winning novelist, but also oncologist and entrepreneur, said it's AI and MD, not AI or DMD. He's obviously using American terminology, but I think you know what I mean. So you already spoke, Simon, about supporting high intense processes that would have taken people a long time. It's similar to that in imaging. If we think of a radiographer capturing a scan and then that being passed on to the radiologist to interpret, there's just a big load and there's a lot of patients to see. If we can use automation and AI-powered automation to prioritize those images to make sure that suspected cases of suspected disease can be prioritized. And the reason I'm using the word suspected, because it is the human that will make the ultimate decision. We obviously in the company have this brand AI automation platform, which supports exactly that, processing and categorizing images, analyzing and detecting suspected abnormalities, and basically helping the radiologist and any other clinical expertise get to it sooner. And then also AI for clinical decision, which is detection, diagnosis, and follow-up. The earlier something can be diagnosed, the more likely that there will be a positive outcome for the patient. So then some examples of technology that's been developed around the world, because this is all a global effort, but some of the AI technology at the core of it here in Edinburgh. First of all, to help reduce time-intensive clinical tasks, we've got this algorithm that's called automated scan planning that's integrated into the Aquilian scanners from Canon Medical. So when somebody is scanned, in the past, technicians would have to manually adjust the position of where the scan would be performed. And now that's done automated through basically making sure that that bounding box is at the right place for the scan. Now, it may seem quite simple, but all of us are different shape, different size, different anatomical features. So doing that accurately and correctly for every patient and also saving time to for the operator makes a big difference. The reason why it's called the automated scan, 3D landmark scan is linked to our is acquired by an ultra-low dose three-dimensional helical scan, and then it basically looks for different anatomical features. So the algorithm that's been developed is called for short ALD, but it stands for anatomical landmark detection. So it's anatomical landmark detection that helps the automated scan planning, and that's integrated all into the scanner itself. Following that theme of anatomical landmark detection, we can also look at how and where it's used for clinical decision support. So moving in a slightly different clinical area and looking at oncology. So bone metastasis can be interpreted through use of a bone subtraction app, which is actually running on this automated server that's called automation platform. And the radiologist or the oncologist can see lesions that might not have been there last time when this patient was seen, and the different sort of color coding that is just about visible there. You can see in red a new lesion, and the numbering of the vertebra in different views, which isn't always easy to see if you're not seeing it in the one on the far right, is displayed in green. This makes it possible for them to identify the exact location of the lesion. And it's that vertebrae labeling that's deep learning based that's been developed by a team in Edinburgh. Now, all of this is, as you said, technical work. It's fun, it's difficult, it's complex, but we have to think about the data side and the social side while we're doing this. Anything we do has to work on all of the target population. In that example earlier of automated scan planning, people are different, but it has to work on everybody. Are we always going to have all of the data for everyone in the world? It's really hard, but we have to try and make sure that we have to put at the core of all of our processes that the data that we train on, test, and validate needs to be diverse enough. But we all also, as both patients and people, want our data to be protected. So it's not easy to get hold of that data, which is why we have to look at ways to get data accessed ethically and without any issue of privacy being in any way adversely affected. So this is why safe havens or trusted research environments are on the rise. So in addition to sort of algorithm work that you've seen, we've also developed this platform called Safe Haven AI platform that is the first research environment that's been directly linked to national pacts and has been developed by my colleagues from the decision support team. Global regulatory bodies all around the world are rightly increasing the need, the quality and the ethics bar. It's always been the case that you cannot put something in healthcare, even before we had AI, without meeting the standard, but the standards and the bar is being risen every day. There's plenty to read in here, and actually I put some of these links. I don't know if these get distributed, but it's just to illustrate the timeline of how FDA is trying to change its guidance and change it quite fast for a regulatory body. But the summary day of good machine learning practices, and maybe some of the stuff we'll be discussing later, is that you really need to have multidisciplinary expertise at the core. You can't have just engineers developing stuff for healthcare without clinical input or validation. You can't have only the technicians or the IT department from the hospitals. So it has to be a cross-functional and cross-disciplinary approach. Good software engineering practices, security practices, making sure that training data sets independent of test data sets, and the list goes on. These are just headings from a pretty sort of meaty document, and they are also like providing most recent one in March, really how all the different, this is the acronyms of all the different US bodies need to be working together to make sure that the tech is moving faster than the regulation, and obviously that's not quite the right thing. However, nobody that works in AI and healthcare or just in healthcare is going to just pick up something that's evolving just now and try and put in a product. The checks and balances are there. And finally, in that whole theme of co-creation and validation, this doesn't start in industry. This has to start in academia and also in clinical centers. So clinical involvement from start to end and academic research needs to follow the same practices. You may not know that actually quite a lot of this leading edge work is happening in Scotland and a lot of it in Edinburgh. So, we should be proud of that. Just a couple of examples, and I'm sure that fellow panelists have others, that we work closely with Edinburgh University, and Professor Sotos Saftaris is Canon Medical Royal Academy Engineering Chair in Healthcare AI. So I think the job title shows all about his focus. He does research in many different areas of healthcare AI. Because we'll be talking about bias and fairness today, I just highlighted the latest paper that he's done with some of our scientists and students based at Canon Medical about looking at detecting shortcut learning in neural network to help improve generalization of solutions to target population. And then he's the director of this hub that is being launched in Edinburgh in June. I think Data Lab are one of the partners and sponsors that will be focusing on causality in healthcare AI with real data. Multiple universities are involved, multiple industrial bodies, and hopefully some of this cutting-edge innovations to enhance patient care and outcomes will come here from Edinburgh. And just to finish off, Edinburgh-Glasgow rivalry. We work equally with both, and Living Laboratory are doing some fantastic work to just improve validation of clinical solutions. So example of radiogenomics project that our teams are working with Professor Kevin Blythe, 1,400 patient database of patients with non-small cell lung cancer, containing clinical imaging and also genetic information. And the idea is to develop and validate the models that can then be generalized to other patients with cancers. It's all anonymized, and data needs to be used in a way that no patient that's part of this project would ever be identified. Thank you.
Other Scottish universities also available. Thank you very much. That was a really good talk. Really interesting to see some of that work's been going on a while. I've sort of seen that quite a while back, and the early stages of that. So it's cool to see it progress. And some of way back went to uni with someone that worked at Canon for a long time. So it's a really interesting journey to see it going on. And that touch point on ethics, regulation, and it can feel like it bogs down some of the tech sometimes, but it has to. And I think a lot of techies can be quite guilty of like getting overly frustrated when actually it's a really important part of the holistic solution, not just like tech for tech's sake. So yes, thank you very much, Ivana. The last talk today will be given by Shane. If you would like to come up, Shane, and introduce yourself. Shane is Head of Data Science for Linus Health.
Thanks very much, Adam, and thanks very much to Stephen and the Data Lab for organising today's event and inviting me to speak. So my name is Shane. I'm the Head of Data Science at Linus Health. Linus Health is a startup based here in Edinburgh, which spun out of a larger digital agency called StormID. Today, I'm going to give a very, very quick overview of Linus, some of the products we offer, and some of the products we offer, and then just focus on one of them in particular, which is relevant for this event today. Our core product offering can be split into the following streams. So we have Linus Diagnose, which involves the diagnosis of patients with chronic conditions, Linus Stratify, which is the AI element or the risk stratification of patients with chronic conditions, and then Linus Treat. So Linus Treat is quite broad, but you could think of it as a population management view of patients with chronic conditions. Throughout each stage of this process as well, data is collected. So we're at that point now where we have these services live and we are accruing data with the view to be able to do AI end-to-end on each of these aspects. I'll touch very briefly on Diagnose and Treat and then talk a bit more about Stratify. So Linus Diagnose, this was where members of our product team went out to lots of clinical stakeholders, looked at existing processes for diagnosing patients and seeing how they could improve it. So this is about taking processes which were largely paper-based, GP referral letters, and making it digital. And not only making it digital, improving it. So it starts with a referral from a GP, say. This is then triaged digitally, so straight up the team can say, is this person relevant to go for a pathway? Diagnostic tests are then carried out. So for example, if it's a COPD diagnosis, a patient would get spirometry tested. All of this data, including other patient information, so we work with NSS on this for data integrations, is then surfaced and the clinical team can review, and outcome letters automatically generated, sent back to the GP, added to the patient record. Linus Treat, which is another product, this could be thought of as two separate elements. One being the patient-facing app that you can kind of see more on the left, and the second, the clinical view. So what this allows is, it allows patients to manage their condition. It sends out sets of daily questions, weekly questions, monthly questions, asking about their condition, their quality of life can be measured off the back of this. We have integrations with home NIV, so non-invasive ventilation devices, Fitbits and other wearables, and all that data is surfaced to the platform for the clinical team to see. So like that, they can get a population view of everyone in their cohort, or they can drill into an individual patient view and look at all this data holistically. This was the genesis for looking at AI within the company. So the original plan and the development of this surface was to have this kind of view, and it did prove very valuable. The clinical team were able to act off the back of it. But a really valuable opportunity presented itself to use this data and try and do something more of it. So maybe to see, could you use machine learning, some kind of AI to risk predict? And that's where Lena Stratify come in. So Lena Stratify has kind of two ways of thinking about it. One is a population view. If you can run AI and machine learning at a population level, you can anticipate where the pressures and burdens will be. You can anticipate who's likely to crash land into hospital. And then on the individualized patient view, you can see what's driving risk for that patient, how can we intervene, how can we optimize their therapies. This is our current model suite, and we have more in development. These models are built off large electronic health record data. So as Simon described, all that work in aggregating these really valuable historical data sets were used to train some of these models. And they're also built off that data we collect in these population management services. So we have a mortality risk model, readmission models, and admission models. And those kind of timeframes are flexible within the technical challenges of the problem. So like that, you could alter a 6-month prediction to be a 1-month or a 3-month prediction. And again, these are driven off things like labs data, prescribing data, admissions, any diagnosis history a patient might have, and then that data collected in the service. This is just a quick snapshot of something we co-developed with the GGC clinical team, and we might get into a bit more on the panel discussion. But this is a model that we have live in clinical service, and this is like a clinical checklist. So I'll probably discuss it a bit more, but these are the kind of things we consider. So you have a model that's live. You might want to update it, or it could be a model you're looking to put live as part of patient care. What do you need to consider? And these are all the kind of aspects, and Ivana touched on it as well in her talk. But it's looking to see, is this model performant? Does it have clinical utility? And this is something we go through in an afternoon session with the clinical team, say. So I'll show what this looks like shortly. This is our COPD Insights app. This is a screenshot from it. This was, well, we went live with this just over a year ago, and it's the first of its kind in the COPD space. It's live AI being used on patients to inform their care, to help risk stratify them. And this is with the Greater Glasgow and Clyde Health Board team. This was our first model run. It doesn't look as impressive as there's only 17 patients, but now we're in the hundreds, and we're running more than one model. We're running 4 models. So this is the first model run as it was being run on live patients, and is looking at mortality risk. So looking at that distribution, most patients sat in that 0 to 20% risk, bearing in mind that risk of mortality in that population sits around 8%. And somebody was in a relatively high risk category in the 41 to 60%. This is what the view looks like when the clinicians dig in on an individualized patient level. And just to kind of understand that plot, anything moving to the right is increasing a patient's risk, anything moving to the left is decreasing the risk. So I'll go on to the next one just because it's a bit more interesting. So again, bear in mind that this was a real patient. So their mortality sat at 57%. So if you think of your baseline as 7%, that's a really high mortality risk. And we've had to redact a few of the features driving it on the left, but the 4th one down was really interesting to the clinical team. The patient had a recent episode of respiratory failure, which they were not aware of. And that was one of the things driving this risk. Off the back of that, the clinical team said, we need to optimize their therapy. Through the service, they sent a check-in message and brought that patient in for review. So like that, they can have a look at this. There's obviously a lot of things like a patient's sex, you can't change that. Certain bad lab tests, you can't change them, but there are factors that you can influence. So something like respiratory failure, was there a reason behind that? That's what they look to do from this. So again, it's moving beyond the, okay, you have a model that's performant and works really well, but what do you do about it? So it's looking to drill down and say, how can we intervene? How can we act on these patients? And as I say, this is in the middle of a MHRA clinical trial at the moment, and we're in the follow-up period of that now. So that was a very, very quick overview of some of the things we're working on. We are looking to hire, we'll be starting recruitment again in about 2 or 3 months, so follow us on LinkedIn and look out for the job posts. Thank you.
Thank you very much, Shane. Really interesting. And the visualization there was really quite, what's the word? It like hides a lot of complexity. I think I know how much goes into even just designing an interface that's easy to drill into like that. It's like not an obvious thing. It takes work and effort. So really interesting application. So I hope you've got some really hard questions for the panelists as I invite them up to join me up here. I think I get a seat as well, so I'm going to sit after I've come and collected some questions from the audience. So as you take your place, I'm going to throw you a softball to get moving, I think. We've talked a lot about some of the outcomes and some of the cool stuff you can build with a big team and like a lot of experience and applying research to a really difficult domain. How do you find early career people being ready for the workplace? And if you were starting now, like fresh out of university or looking at a master's potentially, what kind of skills would you optimize for? What projects should you be looking at on the side if you want to break into this space? Anyone?
I can start and can complement each other. I think there's 2 sides to it. One is that right now, some of the people coming out of university would have been affected and had the education learning journey affected by COVID. So I think that would, for anything, not just for this sector, be take advantage of meeting the people in that industry and getting a mentor early on. To help build the relationships. But specific to AI, you mean like the whole of, or, yeah, anything. I think it's really just getting that awareness that university prepares you with the foundations. And then you build on them and you won't know whether you'll build them deeply in one area or across. So you might have a perceived set path. And probably if we speak about, after a few years, who stayed on the set path, that's perfect because it means you're gaining expertise. But then other times you'll be like, I'm starting to do this other stuff. Like, for example, you might be involved in processes. You might be involved in testing and validation and divert from whatever path you had when you started. So maybe just don't think there's one set path and build relationships with people.
Anything to add, gents?
Well, so a couple of things. I trained as an electrical engineer originally, and and I'm really glad I did. So I wouldn't change that at all. However, so I moved from academia into the NHS, and it made me reflect quite a lot on how I used to teach in academia, right? So how I particularly used to teach things like machine learning. So if I were a student studying that now, I'd want to focus a lot more on real applications. I want to get out and do an internship somewhere and see what things are like, because I think, and I'm putting myself in this, right? When I was teaching that, I had a very narrow view of a very technical thing. So we've got some data, we learn about the models, we learn about training the models, we learn about evaluating them in a very technical sense. Whereas once you get out into using it, it's way broader. So getting that broader experience. And then from a technical point of view, the kind of things involved in deployment. So when I stopped teaching at Glasgow Uni, so it's like 2021, we didn't have anything really around like machine learning deployments, so containerization, that kind of stuff, right? I think there's some stuff now, and when I see CVs of people coming from other data science courses, I see that, and that's good, because that's, I'm slightly conflicted because I really valued the fact that when I started in that field, I had to implement stuff from scratch, and I think that was really useful. So I had to write like a support vector machine in C++, right? You don't have to do that anymore, so you miss that. Yeah, it's kind of like that's hardcore. So you don't have to do that anymore. So I think people miss that. but perhaps just playing around with libraries isn't quite enough. So you need a bit of that, but then you need the broader deployment side. Like, how do you actually get this stuff to work? How do you get it to work at scale? How do you get it to work reliably so that it's going to run every day? Right? So those things.
Shane, any more?
Yeah, just to extend on it a bit, and some of this has been covered already. I think this whole space is so multifaceted. It's not just technical people or a data scientist working offline building models. There's so many different departments. So product within AI now is a really big area. Governance is very important. Even when you think about deployment or the app I kind of showed there, there's so many different skill sets that go into that. If I was just to focus on one particular area and to extend on your point around deploying models, I'd put a bit of time into model ops. So again, model ops itself was something that, not that it didn't exist, but people were doing it by taking principles from DevOps, say, but model ops now is a booming area and it's so important. And when it gets to a point where you do have models and you want to stage models, update models, having a good grounding in model ops is a really good skill, whether you're thinking of going data scientist, data engineer, or a model ops engineer, which is now a position. I think that's a really, really core skill to have.
I completely agree. And from my experience and exposure from doing events like this and meeting other heads of data science, like, actually there's a kind of like a 1-to-8 ratio of like one person that knows how to deploy stuff to 8 people that have just deep mathsy knowledge of the tools, and you can really stand out with just a little bit of that, being the only person that applies with those kind of skills. Really want to open the questions up to the floor. First hand up, I'll just come over.
Yeah, hi. Great talks. Has any AI product been passed FDA approval or European devices approval at all? Or, especially for the diagnostic markets, not for the administrative markets?
From the 2 examples that I gave, the scan planning is deployed on the scanners, and I can double check, but I think it's been cleared for every global region, because if the scanners are deployed, so it will be part of the scanner approval. I can check that for you for sure. And the other one, which was for oncology use case, it's deployed only in Japan at the moment. I need to check the exact reasons for that, because we don't always target every product for every region for like business reasons. But there is a list, it's actually just been published maybe a week ago on FDA website of all the approved medical imaging devices that use AI and machine learning. Is more than 300 on there. It's like a filterable table, and about 50 of them are linked to, say, Canon scanners and products. So it is a useful list to look and see what's been approved. Even though the bar for approval is high, obviously plenty of products from different companies are making it.
And just to sort of riff on that a little bit, is that an achievable thing if you're not Canon, like a big Canon-sized company?
So the research center here provides the technology, and then we work with our partner sites in both America and Japan that actually do the heavy lifting for that part. So I think it's challenging for everyone, but obviously having the skill set and the in-house, we have a really good regulatory team in Japan and America helps. I think when you are a smaller company, that's where actually really come in. There's kind of platforms that the smaller companies can come to and provide some of those.
Consultancy called Meetup, and I think all 3 of you white paper and the 10 or 12 things, and the first one is multidisciplinary expertise. So could you all mention maybe how you all use humans in the loop when you're developing those AIs? Thanks.
Shane?
Yeah, that's a really good question. We've been really lucky at Lena's Health that we have strong clinical collaborators. So say if I take any of those examples of the models I mentioned, they were in development for a couple of years. And we use tools like, say, SHAP for explainability, and we'd sit down with the clinical team. We'd explain what SHAP is, first of all. We'd explain what it means. We'd go for all our feature engineering, how everything is derived, and they will say to us, okay, yeah, that makes sense, or no, this doesn't make sense clinically. This isn't bioplausible. So we get that kind of assurance from day one, and we really, when it comes into everything around biases or just, Scottish healthcare data or healthcare data in general is so rich with bias. Some of them can be quite useful, but just to really talk that out with them, and that's been so important. And when it came to actually deploying the models and going live, when we go for those model runs, we would do that collaboratively. So we'd feedback, and they'd always be in the loop. So that's been one of our strengths as a company.
Yep. So the example I gave, I mean, that's we will run a calibration for PHS, right? PHS have a lot of expertise in what they expect to see. So we run it, we give them back the results. They might come back and say, can you change some stuff? I mean, they're absolutely core in that loop. And what I think one of the useful things that provides is that they can then basically query this model, right? So that's really what the end goal is. It's not to say, here's the optimal set of variables, that's it. Like, it goes straight back to them, and then they look at it, and sometimes, because of the way we optimize, they won't pick the best one because it will have missed out some periodicity in the output or something. So they're completely in the loop, right? It's just rather than them having to drive this optimization, it gets done, and then they add a bit more.
One final example, because obviously medical imaging requires clinical expertise to create ground truth. So we work with our clinical collaborators and clinicians to create the ground truth that will be used for model training. But then we also have to do inter-observer and intra-observer analysis where different, which is part of something that is part of good practices, whether FDA says or not, because sometimes clinicians as people will have different opinions and they will not agree, and then we have to figure out a way of what's the level of disagreement and what's the likelihood that that level of disagreement, if it's picked up in the model, could cause an issue, or how to resolve it. So yeah, hopefully answers your question.
Right, we have a question here, and then I'll come here.
Thank you very much. Really nice talk. Related to ground truth, actually, I was wondering, how do you take care of the systematic uncertainties of your input parameters? And is there a significant effort to actually study and understand them and the effect they have on your, say, prediction or your simulation or identification? Thank you.
Discrepancies in the ground truth sets, or
yes. Also, I mean that if you have your input set of features, if they have some systematic uncertainties on top of them, yeah.
Okay. So part of that is hopefully preempted through good inclusion criteria definition for the data. The other part is also depending on the architecture and the of what choice you have for implementation. It depends how many modalities you're looking at as well. For healthcare informatics, it has to work on all vendors, so multi-vendor data. So you can't just go and go by what you know from your female known scanners and protocols. Yeah, I think all the scanning parameters, if it's scanning data, all the field of view, all these kind of things are going to help define the inclusion criteria for a specific clinical use case. And then from there on is the architecture and implementation. Don't know if you...
Yeah, it's a good question. I think if I take the example of some of those models, the power that we have in them is that they're trained on huge amounts of data. So say tens of thousands or up on 100,000 patient records. So you have to accept that trade-off that there is erroneous data in there. And in terms of what kind of investigations we might do, that's a big part of the work, and that's always ongoing. So it's looking at understanding, say, for example, simple things like, is something truly an outlier? Is there value in that? Is it physically possible for this machine to measure a lab test at this value, for example? So those kind of investigations are ongoing. So there is a trade-off you have to deal with of having this huge data sets, but you're not in charge of the data collection mechanism. It's data that already exists and is collected by routine means.
Just on the back of that, is there any effort using the real data to create synthetic data, simulated data, so that you have?
Yeah, I guess I can kind of speak from the company I work for and for Safe Havens in general in Scotland. Safe Havens do a lot of R&D work, and they are looking at solutions for synthetic data such that people don't have to go through these huge governance approvals. People can be put on projects with very similar synthetic data. Some of them methods are quite simplistic, some are quite advanced. We don't do the advanced ones ourselves because we'd have to hold it in the same protected environment. There's a fear that you're risking the patient data by using those characteristics to generate new data, if you could reverse that process. So it's one, if we did it ourselves, we'd have to keep it within that lockdown environment. But Scottish Safe Havens are researching a lot into that at the moment.
I'm actually linked to synthetic data. Obviously, one of the intended uses of it is for data augmentation, but for very safe cases. So maybe to enhance the testing of the non-clinical part of the algorithm, yes, but to put synthetic data into trying to, validate something fully for clinical use in patient, that's still an evolving field and one that everyone's following with a lot of interest.
So I was going to ask a question back actually. Do you mean you're generating synthetic data for then training models on?
Or more, could be, yeah, but also for validation.
Yeah, I guess I'd echo that. I think it'd be very hard to validate on synthetic data. You'd still have to validate on the real stuff. I kind of feel like with quite a techie hat on, generating synthetic data that accurately respects all of the relationships in the data is probably harder than building the AI model, right? So
that's all. If you can do that, that already solves you a lot of problems.
So, I mean, if I can hire someone who can generate really good synthetic data for that problem, so we'll just train the model, right?
Yeah.
And off-the-shelf stuff, as someone said, releasing really high-fidelity synthetic data out of a safe environment is very risky, I think. No one really understands how much you could then reverse engineer from that. So
interesting, yeah. It's good.
Thank you. Right, we had another question here.
So all very interesting talks. Thank you very much. We hear a lot about the challenges of privacy, and it's nice to see the safe havens making an impact. We could talk about how much impact they're making, but there's another facet which I think is not been mentioned, is data interoperability. So how easy it is, particularly if you've developed an algorithm or a tool or product in one context, maybe plugging into SEER, for example, it is to then take that and commercialize it at a global scale where you can plug that into the healthcare ecosystem anywhere when the standards are weak and the tools that are in use will vary widely. Could be Epic at one site, could be completely different EMR at another. Any views from the panel on healthcare interoperability standards and the ability to plug these tools into a hospital system anywhere?
I'll start off. I think it's a HIMSS conference where it happens every year. That's often a trending topic there. It's a big topic because there's different ways of technically solving interoperability, but then you get into every clinical workflow, even though on PowerPoint will look the same, it will differ in every hospital, right? And so if you then, because it's a healthcare setting, something plugs and plays technically well, but it doesn't provide the right clinical information, then we actually, the good reuse from a technical point of view could really affect the clinical use. But in terms of like technical solutions, look up the latest kind of HIMSS conference talks, and there'll be plenty of information there.
I can add on that, yeah. It's a massive challenge that we face, for sure. We have different kind of approaches to that. First of all, let's say if we train a model on Glasgow data, we wouldn't expect it to generalize outside of Glasgow, and you shouldn't. Even if you strip the features back to really core clinical information, so things that are diagnostic, even then you might get something that's generalizable. But when you include quite rich information, so say for example, days since somebody had a labs test, so that could turn out to be really meaningful, but not for the right reasons. That could indicate that they had a GP visit. So it's not really, the causal aspect is missing there. So our kind of view on that is, while Canon want models that will work across all ethnicities, all demographics, different regions, we're more of the approach of doing like targeted validation. So if we move to a new place, we want to retrain the model, validate it, and show that it can work well on this geography. In terms of how you do that then is very challenging. So we would typically have different versions of models, one where prescribing data might be missing because you can't access it in this system in England, for example, and you retrain a model and you accept that it's going to have slightly lower performance. To help with that, we look to work with common data standards like OMOP, for example. So then I know there's a big shift within the TRE SD networks in England to standardize data to OMOP. When we get to that point, it'd be quite easy to retrain. As it stands at the moment, you're going into each new place and the data is structured differently. So you have to go through all that transformation before you can retrain your models. So it is a big challenge, but one that is getting slightly easier with the likes of OMOP.
So we've got 8 minutes left. There's been a very patient hand up the back here, so don't just bear with me a minute, and we'll come and join you. Here we go. Because big voice, because that's just for the big.
No worries at all. Really, guys, thank you so much. It's really great to be here today. I just want you guys to talk about people, just move from technology to people. I guess the reason is that the whole essence of technology is about, just enabling lives and making lives more meaningful. Would you all agree? If that's the case, can you just talk me through how, from your perspective, what are the timelines? You see develop stuff, take it to the market, or put it in the end user's hand. And what are the challenges that you have with people, within team, keeping them almost excited in what they're doing? Because I know these things are not overnight. It takes a bit of time. Keep them excited to get to the finish line. So if there's any thought about that, please.
I mean, it's a really good question, right? Because things can be pretty frustrating. If you're a technical person, like I'm surrounded by data, which is amazing, but it's frustrating because you can't always do stuff because you need to be asked to do stuff. How we do that? I don't know. Maybe this is maybe it's like controversial, but I think if you're kind of motivated to work, say, an organisation like the NHS, maybe you're patient about that because you're driven because you want to do it. Now, that's not to say anything against other organisations, but maybe we're kind of slightly self-selecting for people who are willing to put up with that frustration, because if they get frustrated in a few months, they're going to leave and go somewhere else. Right? So maybe but that's not a great answer. I don't have a great answer. Just be nice to people, ask them nicely. I don't know. I'll let you do better than that.
It's a great question. And obviously, every project is different. Giving people focus time when they need focus time, and then giving them space away from when if the project is going to be few years, right? Maybe some people just need a bit of space away, and we have like advanced development projects. People can go away for a few months, work on something else that's also, in the same area. It might be in imaging and visualization, and then come back, and they'll come back often with fresh ideas, or often tech enablers. You mentioned the benefits of deploying things. People would come back and say, okay, we're now going to start converting some of the Python models to C++ to make them more productizable when that's required, because it's not, it depends on the context. So having enough variety of work helps. But also, I mean, persistence, having tenacity and people in the team, you said self-selecting, but I think in every industry, you have to expect part of that. So it's about the culture that you build in the teams and people helping each other. I mean, that might sound like a cliche answer, but it really does come to that. And if you don't have that set up, then people get frustrated and they might, leave and go work on something else, which is obviously what we try to avoid.
Okay, can I jump back in?
Sure.
Yeah, no, I think just two other points, right? I think remote working, COVID makes it much harder to build that kind of team environment. But the other one is when you do get something into production and it's working and you can see it's useful, it's a real kick, right? So, maybe there's frustration, but then you get those boosts and it kind of keeps things going. So you can see real effects. Yeah. So, yeah.
Yeah, I'll just add a very quick one. That is a challenge to say that the models we put live from development to going live was almost 4 years. So it's a really long time, and people do get dejected because a lot of data science work goes nowhere. And that's the kind of reality of it. It becomes R&D. People are typically very siloed. A lot of the time, it might be a one data scientist team, so they're just working by themselves. I think things that help are doing things like hackathons. So say, how do you put a model live? Getting people in for 2 or 3 days on a workshop, trying out different technologies, giving people R&D time. So something that is nothing to do with the core products at the moment, but letting them explore new technologies, presenting that back to internally or to stakeholders, just to get a bit of enthusiasm around the work people are doing. Because it's hard to get the appreciation if you're working on something focused for a couple of years before you actually see the result.
Time for a couple more questions. Any up the back? Save me a walk. We'll start here.
Hi, can you hear me? So even though there is lots of healthcare data out there, at its core it is inherently sparse, especially around black swan events, like really serious things. How do you develop models and systems that work to make sure you pick out those really serious events while still making sure those models can work for a general population and not have like too many false alarms or, you know, bad workflows?
I mean, cybersecurity or models not working on wider population? I didn't fully understand you.
So if you have like 100,000 people, for example, you might have 10 people who'll have an aortic dissection,
okay.
for example, and you're building huge models on this. And aortic dissection, very important to catch, but if someone's coming in with like a chest pain complaint, they're more likely to have like, what's it called, acid reflux or something like that. So how would you balance those two while making it usable and not saying everyone is like super sick?
Thanks a lot. It clarifies the question nicely. So earlier, when you were asking the kind of technical question, I talked about inclusion criteria, but actually, if we make the inclusion criteria for an algorithm too narrow, then we will only be able to, you know, detect or treat a very niche part of maybe a wider disease area. So we have to make sure that not just in our training set, but in the validation set, we have enough of the cases that may be with rare pathology rather than the one that's intended. And it's really hard to get that balance because sometimes you can't get enough data sets even for training for something that's quite rare. So this is where we rely on, before it's deployed, on clinical evaluations with external collaborators because they will have, especially in safe havens, access to wider data sets and it's sort of blind evaluations of the models, not trying to sort of pollute it internally. And it's that feedback loop and why it also takes time, then we can benefit. But sometimes we find out that the particular implementation has limits for maybe when you extend the criteria, and then we do a different algorithm or do a different implementation because it's not going to work as well on particular patient set. So yeah, it's the feedback loop and the iteration of development.
Jump in. So I think it touches on a really interesting aspect of interdisciplinarity that maybe gets lost sometimes. Because I think if I was to rephrase your question, it's like, well, if you're building a machine learning model, you're optimizing some cost function. And if you give it to a tech person, they'll maybe optimize AUC or something, right? That's an average metric. And what you're saying is you've got a really small group, and that's just swamped in the AUC. So I think the interesting question is, what should you be optimizing and who decides? Because I think that's a really hard decision in a domain like that because you're effectively balancing your performance in these different groups. And that's not really a technical question to choose that, if that makes sense, right? So I think that's where we need people who are maybe, like people would say a health economics background, who have some machine learning and tech expertise to be able to have that conversation and say, well, actually, these are the important things to optimize here because this is the cost of making the different mistakes. So I think it kind of speaks to this, that these kind of problems are really broad and not just, here's a data set, maximize AUC, right? Because that's going to lead to things which, as you've so actually the errors and what are the intolerable errors.
Is actually an adjustment.
Both of our remit health will be coming Edinburgh University.
Thank you very much. I'm a Strathclyde grad, so I'm not buying any of it. Anyone else? I've got time for one more because these big 30-second chunks have chewed up a lot of the time. Right, I'll go here because this gent didn't get a chance to ask a question.
Hi, thank you. Ravi Banabai, you can look me up on LinkedIn. I'm an IP AI developer, so I develop IP and AI and algorithms for any of an idea and are looking for help. I'm here to help. So just feel free to connect with me, Ravi Banabai. Let me know.
Thank you very much. So, Party Pooper, I'm going to draw that section to a close. I mean, you're welcome to just stay in this room and shout at each other, that's fine. But I have an official duty to, first of all, for some people to build the courage to get up and answer rando questions from the audience of clever people. So, look, really appreciate that. Thank you. Join the community. There's a QR code. Thank you. Genuinely, it's an absolute goldmine for just like whittering away to like-minded individuals, getting access to the mentorship program where you can get paired up with like some really experienced people across the data and AI sector to hear about funding, see interesting entrepreneurs stuff, meet loads of people, get free pizza. It's the